Good afternoon and welcome to another video. So in this particular session we are going to check how binary search is used in C or any other programming language for that matter. So in the previous video I had taught you how to use linear search. Now we are going to explore the process of binary search. So you see, in linear search the main issue is that if the size of the array is very large, a lot of time is wasted in searching through the array until and unless we find the desired element. So on average the complexity of binary search is O(n). That means the time spent in looking for the number that we want to search is almost proportional to the size of the array. So therefore if the size of the array is small, it will not take a lot of time, but if the size of the array is very large, say 5,000, 7,000, 2 million, whatever, then it will take a very long time. So to overcome this problem we have developed another method called binary search. So let us see how binary search works. So here you can see it says that it is a divide and conquer strategy. It continuously divides the search space in half, inspects the middle element and repeats until the target is found or the search space is exhausted. So what it will do is, before binary search, one thing that you have to keep in mind is that the array must be in sorted order. Okay, you cannot perform binary search on an array where the elements are scattered in a random fashion. The elements must be sorted either in ascending order or descending order. Otherwise binary search will not work. So for the sake of this demonstration we'll take the array which is sorted in ascending order. Okay. In linear search you don't have this constraint. In linear search, even if the array is unsorted, you can still search through it. But for binary search logic to work, the array must be sorted in either ascending or descending order. So what are the steps? Find the midpoint index of the entire data set. So we'll find the middle position. So middle position is usually given by the index of the first element, last element, and it is divided by 2. So here you can see there are 10 numbers as there are indexes from 0 to 9. So 0 plus 9 by 2, that will give us 4. So that is the middle position. Compare the element at the midpoint against the target value. If it is equal, return the index of the match. If less, repeat search on the left half. If greater, repeat search on the right half. So essentially this means if we are searching for a number which is lower than the value that occurs at the middle position, we will focus our searching only on this part, not on the remaining part. Okay. So as the array is already sorted, if we are searching for a number which is less than the number in the middle, which is 16, say we are searching for 5, so it will be obviously in this part. Okay, it cannot exist in this part because here all the numbers will be bigger than 16. Similarly, if the number is bigger than the number being compared, if the number that we are searching for is bigger than the number at the middle, that means it will occur in this part. So if we are searching for a number like 72, it will occur after 16. So in that case we are going to focus on searching in this part. So like this will continue as long as the desired element is not found. And if the number at the middle matches with the key that we are looking for, then we will say that the search is successful. So here in this example they are searching for 23. So initially they have calculated the mid position at 4. So at 4 there is 16. So 23 is bigger than 16. So we will search in this part of the array. So here we will take the first index as middle plus 1 and the last index which was 9, it will be 9 only, it will not change. So we will search in this part and if the number is found we will return the result. So here also once again we will find the mid position. So between 5 and 9 the mid position is 7 because 9 plus 5 gives us 14 and 14 by 2 is 7. So here at 7 there is 56. So we are searching for 23. So this is not a match. So 23 is less than 56. So it will occur in the portion previous to 56, that is, it will occur in the first half of the array. So now we are going to compare the number with this part. Okay, so once again in the second half we are going to recalculate the mid position. So the second half, in the first half, not the second half. So if we are taking this entire portion of the array, this is the second part and this is the first part. So as 23 is less than 56, it should exist in this part. So to search for the element in this part, once again we are going to calculate the mid position. So mid will be 5 plus 6 by 2. Okay, so 11 by 2. So it will be 5. So now we are going to compare the value in the mid position with the number that we are searching for. So we have found, after comparing this number with the number that we are searching for, there is a match. So now it is going to return 5. Okay. So here is the algorithm. Set lower index equals to 0, upper index is size minus 1, that is the size of the array minus 1. Compute the mid position. So as I have told you, mid position is computed by lower plus upper index divided by 2. If the array at the mid index is the target, that is the number that we are searching for, the key, return that index. Otherwise, if the array at the number at the middle, if it is less than the target element, set lower index is equal to mid plus 1. So if the number that we are searching for, it is bigger than the number in the middle, that means, say in this example we were searching for 23, which is bigger than 16, so it will exist in this half of the array. So to concentrate, to continue our searching in this part, we are going to take the lower index as mid plus 1. Okay, because we are going to search in this part only, not in this part. So lower index, which was initially 0, now it will be mid plus 1, and upper index will stay the same. Similarly, if the opposite thing happens, if the number being compared is less than mid, lower index will be the same, but the upper index will be reduced to mid minus 1, because we are going to search in this part. Repeat the steps until the target is found or the search space is exhausted. So if the entire array is exhausted and we still haven't found our element, we'll have to assume that the number does not exist. So now let me see the code of binary search. Okay, so this is the process of binary search. So here we have taken some numbers. Again, there are 5, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there are 8 elements. So now they have taken the size of the array. So they are dividing the total size of the array by the size of a single element, and that is giving the number of elements inside the array. And key is the element that we are going to search for in the array. Now we are going to pass these 3 parameters, that is the array itself, the size of the array, that is the number of elements in the array, and the value that is being searched, to the binary search function. So inside the binary search function, as long as the value of low is less than or equal to high, we will continue. So low is initially, it is the first index, which is 0, and high is the last index, which is n minus 1. So middle will be equals to low plus high divided by 2. So this will be the middle position. So in case of this array, so if it is 8, so 0 plus 7 by 2, it will give us 3. Okay, so 3 will be the middle position, and we will have to compare the element in the middle with that of the key that we are searching for. And if the number being searched matches the element, that is, if the array at the middle position matches with the number that we are searching for, then we will return the index of the mid position. As I have shown you previously in this, not here. Here I have already shown you what the process is. So the same thing is happening inside this code. So if the number that we are looking for, it is less than the number in the middle, we will search in the first half. To search in the first half, that means to search in this part of the array, we will reduce the upper index to mid minus 1. So if the array mid is less than the middle value, then high will be mid minus 1. But if the array if the number that we are searching for, if it is bigger than the element in the middle, say we are searching for 72, so it will be existing in this half. So in that case, we'll have to change the lower index from 0 to mid plus 1, because we are going to search in the span of the array from 5 to 9. So this will continue as long as the number is found, otherwise it will return -1. So -1 means the number was not found. So once a value is returned, the control passes back to the parent function, which is the main function, that is the calling function. So if it is not equal to -1, it will print the number, otherwise it will print not found if it is -1. So now the complexity of binary search. So it will divide the array. So binary search, how it works, as long as we have at least one element, will continue the division. So it is a divide and conquer process. So it will continue to divide each half of the array until and unless we are left with just a single number. Okay, and that happens log n times. Okay, so for that reason the complexity of binary search is log 2n. Okay, so we are essentially, k means here the k variable essentially means how many times we have to keep dividing the array until and unless we get just one element. So 2 to the power is k. So if the size of the array is n, okay, and 2 multiplied by k gives us this, so we have to divide it by 2 to the power k as long as we are not getting only one element. So k essentially gives us how many times we need to keep dividing the array by 2 till we get one element. Okay, so that is the reason we are getting k over here. Okay, so let us see the complexity. If it is found at the first comparison, it is 1, because then it is a constant time. Average is log n, and worst is also log n. So this is the process of binary search. I hope you've understood this. So this concludes our 2 videos on searching. First was linear, second is binary search, and I'll see you all in my next video. Thank you.